Question 4. A sample of titanium was ionized by electron impact in a time of flight mass spectrometer. Information from mass spectrum by isotopes of titanium in the sample is shown in Table 2. This is Table 2. Calculate relative atomic mass of titanium in the sample. Give your answer to 1 decimal place. 2 marks. So, yep, it's just going to be times this plus times this. So let's do it. 46 times by 9.1 plus 47 times by 7. What's going on? 7.8 plus 48 times by 74.6 plus 49 times by 8.5 all over the total. I'm just going to put a calculator to make sure it adds up to 100, and it does, over 100, and we get all over 100. Get 46 times by 9.1 plus 47 times by 7.8 plus 48 times by 74.6 plus 49 times by 8.5 over 100, and we get to 1 decimal place 47.8. 4.2. Round equation including state symbols to show an atom of titanium is ionized by electron impact and give the MZ value of the ion that reaches the detector first. So we know it's titanium. It's going to be Ti. What's going on? In gas, arrow Ti plus gas plus E minus. You just need to memorize how to construct these like as a formula from X grams to X plus gram plus E minus. This is for electron impact, and for electrospray is different. And give the MZ value of the ion that reached detector first. Well, it's going to be this one because it's 46, lightest ion, so it's going to reach the detector first. 46. 4.3. Calculate the mass in kilograms of one atom of 49 Ti. Well, we know that 49 grams is going to be 1 mole. We're trying to find a 1 atom. Or 1 atom, this is all like unnecessary, because 9 times out of 10, if it's a 1 marker and it's got the Avogadro's constant, you're just dividing this by Avogadro's constant and you divide it by 1000, which is what we're doing. We're going to do 49 divided by Avogadro's constant, 6.022 times by 10 to the power 3, times by 1000. The reason we time by 1000 because we need to divide by 1000. Actually, let's make it less complicated for you guys. More understandable. 49, the mass. We're trying to find of 1 atom. We're going to divide by Avogadro's constant, 6.022 times by 10 to the power 23. And then we're going to divide by 1000 because we want it in kg. 49 divided by 6.022 times by 10 to the power 23. And we get 8.14 times by 10 to the power minus 26. 8.14 times by 10 to the power minus 26. The reason we want it in kilograms is because K equals a half mv squared, which is what we use to calculate kinetic energy of the ions, is that requires, in order to get kinetic energy in joules, it requires mass to be kilograms. So that's why we have to calculate kilograms. But you should get that for 1 mark. And now for the final question, don't know, let's get rid of this. That's going to take a long time. Forget it. Let's get rid of it. So it's a time of flight question. Yeah, I just figured it. We'll start from here. A lot of information given. So yeah, that's the equation we're given with. We know d is the length of the flight tube, m is the mass in kilograms of an ion, e is the kinetic energy of the ions. It's usually 2ke, but e in this case represents kinetic energy, so 2ke, 2e, same thing in this case. We know the kinetic energy of an ion in the flight tube is this. So we've got the energy. We know the time of flight of 49 Ti plus ion is this. Calculate time of 47 Ti plus ion. First things first, we already have the mass of we already have the mass of the time of flight of 47 Ti plus ion. This is going to be 47 divided by Avogadro's constant times by 1000, or divided by 1000. And we know the kinetic energy is the same. So we've got the mass, we've got the kinetic energy. All we need now is the distance. And we know the distance is the same for any of the two ions. So what we can do is rearrange this. So we've got T equals D square root m over 2e, m over 2e. Square root both sides, square both sides. We get t squared is equal to d squared times by m over 2e, and now we get d squared, the distance squared, which we're trying to find the distance, is equal to t squared times by 2e divided by m. So that is what we're working with now, this formula. Now we know we've got two ions, 47 Ti plus ion and 49 plus Ti ion. So we're gonna write that d squared equals the time of 47 squared. We're not going to include any detail, but that's what we're trying to find anyway. Squared times by 2e over the mass of 47 divided by Avogadro's constant divided by, what's going on, divided by 1000. That's to find the distance of the time of flight, 47 squared. And we also know distance squared of time of 49 plus ion times by 2e over 49 over L times by 1000, divided by 1000. Or we can just write times by 1000, but it has to be in the denominator. Let's keep it like this. And we know the distance is the same. So we know these two are equal to each other, these two equations. So what we can do is that goes, what else disappears? Because we know these two are equal to each other. Well, the divided by 1000 goes, so what is that? The 2e goes, and the L goes. So we're left with T47 squared equals T49 squared. T47 squared over 47 is equal to T49 squared over 49 times by 47. We get T47 squared equals T49 squared times by 47 over 49. T47 squared equals, well, we know the time of 49 squared is that, so it's going to be 9.816 times by 10 to the power minus 7 squared times by 47 divided by 49, and now we're going to square root the answer, and we get T47 not squared, T47 is equal to 9.61 times by 10 to the power minus 7. So we get 9.61 times by 10 to the power minus 7 seconds. And does it say appropriate number of significant figures? Well, that is to 3 significant figures, so it should be fine. And that is the final answer. That is the end of question 4.